Good afternoon, everyone. My name is Maty Siman, and in the next 40 minutes or so, I'll be talking a little bit about JavaScript security and some new HTML5 cool stuff. Well, I think it's cool stuff. I'm the founder and CTO of Checkmarks, which is a static application security testing, source code analysis. So I will be talking about three main things with HTML5 and JavaScript. Some new tricks, well, the worst security vulnerabilities, all security vulnerabilities with older HTML. I will show you how we can harness the power of HTML5 to make these risks more dangerous. I will also show you some new tricks, and at the end, the fact that HTML5 allows you to do actually put a lot of your business logic at the client side makes your application much more vulnerable. And I will demonstrate all of that. There are plenty of moving parts in the presentation, and I need live internet connection, so I have many excuses if things break, but I hope everything will work fine. So let's start. Cross-site scripting, yeah, you all know, you all heard of, nothing new. I will show you that the fact that HTML5, you can see it over there, the fact that HTML5 is so powerful actually makes XSS much more dangerous than it used to be. So let's start with a very short example. It's a bookstore application. I hope you can see that. It has a reflected cross-site scripting, alert high. That's pretty straightforward, okay? Now, the next step, we found that the login page in here is vulnerable to cross-site scripting. Now, there is another page in the application which I want to steal the information from that page, but the other page is not vulnerable to cross-site scripting. So basically, I would like to infect the other non-XSS page to be an XSS vulnerable. So what we will do is the following. I will actually load the very same page. I will load myself inside an iframe. So the user will think he's using the main application, but actually he will be surfing inside an iframe. So the XSS external site will be able to get access to the information in the internal page. Let's see how it goes. Okay, so I'm loading the login.aspx file, and I push inside an iframe, which loads the very same login page. Okay, so I have a page inside itself. Okay, you can see here I left on purpose this gray border. So the outer page is the XSS page, and the inner page is actually what the user sees and interacts with. Okay, so let's say that I log into the site, admin. I think that I'm in the real site, or I'm actually in the real site. But as you can see, the outer page is still running, and it's able to actually interact with the inner page and still own the information in that page. So for example, if I'm going to the admin page, the outer page can steal all the information, passwords, credentials, and so on and so forth. So I was able to a certain extent, infect the inner page. That's nothing new, okay? It existed 10 years ago. Let's see what I can do with that technique with HTML5. So HTML5 introduced the concept of canvas, okay? A canvas is the ability to graphically interact with the page. And one of the cool features, there's an open source page called HTML2Canvas, which basically takes a screenshot of your page, okay? Converts the page into a JPEG or PNG. So basically what happens now, let me log out. Let me log in. So once again, there is now an outer page which you cannot see, okay? I remove the gray border, but I do put an icon of a camera at the top left-hand side so you can see that something happens. So the outer page, which is vulnerable to cross-site scripting, loaded an inner page which the user interacts with, but the outer page actually takes screenshots of the inner page and sends that to the hacker, okay? So let's see what happens right now if I do a right click and view, open in a new tab. I actually see a PNG, which is the screenshot of the inner page. So the fact that there was a cross-site scripting in one page allows me now to constantly see whatever the real user sees. Okay, it's just a base64 data, which I can transmit over the web fairly easily. Now, the really nice stuff is that this HTML to canvas, as I said, it's an open source code, so I can modify it as I see fit. One of the changes that I've made is that while rendering the page, if I detect that one of the DOM elements is a password field, I convert it to a text field, I take the screenshot, and I convert it back to be a password. So the user can't see that anything happened on screen, but the screen capture takes it while the field is a text field. This means that, well, you can. Okay, so there is a screen capture, as you can see here. Everything is masked, but if I do open in a new tab, I see the password completely revealed. So the user thinks that everything works fine, but as he's working through the application, the hacker can see anything he sees, and on top of that, to see some other stuff as well. So this couldn't be achieved prior to HTML5. So yes, cross-site scripting existed forever, okay? That's our bread and butter. But the canvas concepts allow us to achieve exactly that. And yeah?
Why do I need a canvas to do that? So if you have a cross-site scripting, you can simply extract the password from the password field, so you don't need to make a screenshot of the password to see the password.
Oh yeah, I agree. I think that taking screenshots of the application to see live what the user sees has some more benefit than just statically taking information from the screen. I mean, I feel it's more dangerous, you know, the fact that someone actually sees your screen while you're surfing the application. Yeah, it's good for the reports. That's, I completely agree. Okay. Another interesting concept is the WebSockets concept with HTML5. Let's say that I'm a hacker, I'm sitting outside of your network, you have a NAT, network address translation. I see nothing but a single IP, but I do want to map your network structure, okay? Once again, using a cross-site scripting, I can inject you a script, and then you become an agent of mine. You map the network structure for me, and you send me back the network structure. So I don't have to actually be inside your network. You become an agent of mine. You could have done it prior to HTML5, but it was much trickier and less reliable. HTML5 introduced the concept of WebSockets, where the client itself, through JavaScript, can try and connect to servers. So actually, I instructed to try and connect to various servers in the organization. It maps the structure, and I get back the results. A good example would be the JSRec, an application, okay, where you tell it, everything is JavaScript, you tell it, well, I want to map the network starting from that address to that address. I want to find all the servers that have port 80. You launch submit. It just maps the network and send you back the results. I won't run it now because it's somewhat illegal to map networks, so I'll leave it aside. But basically, you can choose whether you want to use WebSockets or cross-origin requests, and it just sends you back the structure of your network. Okay, so this can be easily achieved through cross-site scripting as well. Something that Krzysztof from Google mentioned yesterday in his presentation was that the fact that Chrome is actually becoming an OS actually makes cross-site scripting some kind of a command injection. And this, he mentioned this statement yesterday, and it's something that I feel comfortable with. Okay, you're actually able to inject commands into the operating system, and that's cross-site scripting. So something that he mentioned yesterday, and I thought it's worth re-mentioning. A little bit about same origin policy. So same origin policy, it's a pretty old concept. It means that a website can interact only with Windows or iframes running from the very same origin, where origin is server name and protocol. Okay, so HTTP or HTTPS or FTP, whatever. And then same website, same server. But in recent years, it is not enough. For example, if you look at Microsoft Office 365, they have a market of plugins where you can just install new plugins from the market. These plugins actually run from the very same origin as your mail server. So if someone uploaded a malicious plugin to that market, it actually, you do not benefit from the same origin policy protection. Same for Salesforce.com, okay? They have the market, the plugins run from that market, so the same origin policy does not provide any protection against these third-party markets. Okay, so with HTML5, they've introduced the sandbox concept, okay? When I load an iframe and I add the sandbox keyword, it means that although the iframe is hosted on the very same origin, you should treat it as if it's running from a different origin, okay? And then it has several parameters. Okay, so the first if you leave the parameters empty, it means you leave all the restrictions and the iframe can do barely nothing. If you add the allow same origin, it means that the sandboxed iframe will be treated as if it's running from the same origin, except for a few capabilities which you have to add explicitly. Okay, so one of the explicits that you need to add is to allow top navigation. So if we have an iframe and we want this iframe to actually navigate it out of its parent, then you have to explicitly add this capability. Okay, the idea is to prevent phishing, that you go to a site and the iframe actually navigates you out of that site. So you have to explicitly add the same origin. To allow top navigation. Allow forms allow the iframe to submit its parent forms, and allow scripts allows the iframe to run scripts. Okay, so I can add a sandbox iframe, so it will be treated as if it's running from the same origin, but for example, it will not be allowed to run any scripts. Okay, so that's the concept of a sandbox. However, there is a fundamental flaw in that concept. And let me show you a quick example. So there are 5 or 6 stages until I show you the exact vulnerability. So if I have a page, a host page, which has an embedded iframe inside it. The embedded frame is hosted through a regular old-fashioned iframe, and it tries to launch an alert message. Okay, so I have an iframe which tries to show an alert, and it's hosted within an iframe. Will we see the alert, or will the browser prevent us from seeing that alert? Okay, once again, I have a page which has another page embedded inside an iframe. Okay, not a sandbox iframe, just an iframe, and the iframe page tries to show an alert. Will that work? Yeah, because the iframe does not provide any protection. So let's click in here, okay? And then we see the alert, hi, okay? Because if old-fashioned iframe does not provide any protection to the hosting page. Now, if we do exactly the same, however, instead of hosting the embedded page inside an iframe, we host it inside a sandbox where all the restrictions apply. What will happen next? Will we see the alert or not? No, okay, we won't see that. I'm sorry, it's the older page, sorry. Okay, we see nothing. And actually Chrome provides us with blocked script execution because documents frame is sandbox and allow script is not set. Okay, so it works as we thought, perfect. Now, once again, I have an iframe. I have a sandbox page where the sandbox allows scripting and allows same origin, and it tries to show an alert. Will we see the alert or not? Just nod your heads. That's good enough. Yeah, we will see the alert because we allow scripts to run. And we see the alert. So far, so good. Now, let's do the following. We have the very same iframe sandbox that allows scripts and allows same origin, but it tries to navigate it outside of its top parent, to navigate to a different site. Will that work or not? It won't work, you're right. Why so? Exactly, because we haven't explicitly allowed top navigation. So let's click in here. And well, we're within the very same site. And the message we get here is there is an attempt to navigate outside and the allow top navigation flag is not set. That's perfect. And now we get to the really nice part. Let me just change a bit to zoom in. The fact that I'm allowed to run scripts and to interact with my parent actually allows me to parse my parent DOM element, my parent's DOM, to find myself as an iframe, to change my own sandbox policy, to add the allow top navigation property, and then to navigate out to a different site. Okay? So the fact that I am able to change my own policies, and then I refresh the page so the DOM rebuilds itself. So now we click in here. You see it tries to refresh, and here we're outside of that page. Okay, so it means that, well, the allow top navigation really is not very powerful if you allow script and allow same origin. Any questions so far? Okay. Oh, it's, okay, so it works only if it's from the very same origin. I just wanted to show that the sandbox capability has at least one problem with it. If it's not from the same origin, it will be all protected.
Hosting malicious content on the same origin as your own site is not a good idea.
Well, it's probably a very bad idea. I agree. That's, but many, as I mentioned, Microsoft 365 actually allows developers to write their own plugins, their own JavaScript plugins, and it's being hosted on the very same server because they provide it as third parties. So that's why HTML5 actually introduced the sandbox concept to allow you to host maybe malicious content on your site. But yeah, I agree, that's could be improved. Yeah. It's a design flaw. That's how it is designed. Okay. There are at least 3 different ways to get to the very same result to actually navigate out. So it's actually the design. Okay. I want us to play a small game. Let me just refresh the screen. So that's a very nice Pac-Man game where it is written in JavaScript. Okay, so nothing goes to the server except for the actual results and statistics. So no, let me just pause it for a sec. Okay, so first of all, as you can see here, the highest score right now is 5, 4, 3, 2, 1. And they chose to store the high score once again, in a new concept introduced by HTML5, the local storage. So now I can change it to 666. And then if we refresh the page, I've changed my high score. Okay, so the fact that, you know, I'm using Pac-Man because it's very easy and funny to show during presentations, but just think about any other enterprise application that you're using. Developers tend to use these new capabilities, these new features, and to actually store information on the client side because it's actually a full-fledged database. So the first thing that we saw right now is that high score. The next thing I want to show you is, okay, I need to put a breakpoint, level min JS 131, just a second. Okay, and let's hit play. Sorry. As I said, moving parts, so things. Okay, so I'm hitting these points, and then, well, it is called the world's largest Pacman because I can go to other screens. So when I try to go to a different screen, it actually it uploads the statistics of my current play. So actually, let's do it in 2 phases. If I do document.cookie, I see this very large piece of code which will get uploaded to the server. And then let's try to look for a URL decoder. And let's decode that. And actually, we see here the statistics. Okay, I was on page -14, -25. I ate 30 dots. I got 300 points, and I died 0 times, and so on and so forth. And now we can obviously change these values in the cookies and hit submit and upload the results to the server. And if you think about it, it's very, very difficult to have written this game differently in such a way that you won't be able to modify the statistics. I mean, since at least some part of the business logic of this game is on the client side, there is no real way to avoid it. The only way would be just to tell the server I ate a point, and then the server needs to accumulate the numbers and send me back the current value. And it will actually have severe impact on the performance. So it's not that easy to think how you could have redeveloped this Pacman game and to solve that issue. So many of the HTML5 applications which allow you to store business logic on the client side suffer from this kind of vulnerabilities. And another nice thing would be the following. Okay, let me just release the breakpoint and hit play. So now I want to modify a little bit, the business logic of the, let me remove the, okay. So now I want to do something else. I want to actually modify the inner business logic of this page. The issue is that once Chrome got the JavaScript, it's very difficult to modify it. So I have to actually catch the JavaScript on transit, modify it, and then send it to the browser. So what we will do is we will proxy the communication. We will start intercepting the communication through burp, and then refresh the screen. Let's hope the network won't fail. Okay, so we got it. Now I just need to, just a sec. I need to copy paste a piece of code. Oh, I'm sorry. Let me. Okay, so I just wanted to copy this piece of code from my presentation, and I will push it. Just a sec. Let me. Another 20 seconds until I find the correct place in the code. Okay, I put it in here, and then let's hit submit. So now let's see what's, so it seems exactly the same, except for the fact that right now all the ghosts are, so when I hit the ghost, they're automatically eaten. So instead of me being dead, the actual ghosts are dead so I don't have to do anything, and I keep killing these ghosts. So that's pretty fun. If you see the statistics of this page, usually there are these pills which allows you to start eating the ghosts, and this screen doesn't have any such pills. So really, there's no real way to eat ghosts in this page. However, as you can see, 33 ghosts were eaten on this page because I guess some other people actually found a way to play that game. So once again, the fact that all the business logic is hosted on your client, I mean, it's nothing new. We all know the risks, but when we analyze the source code of many HTML5 JavaScript application, we found that a lot of business logic is actually hosted on the client instead of just hosting the UI part. And when we start redesigning the code, it becomes not very obvious what part belongs to the UI and what parts actually belong to the business logic itself. So as you can see here, now each time we get a ghost, the points double, so we're actually going to hit max int fairly shortly. Okay, let's wait. So it's fun. And actually, the presentation was a bit, did it a bit faster than expected. So I have this PowerPoint thing in here, just a sec. Okay, and last but not least, I will show you something based on our experience in the lab. It didn't work. Just something freaks out. Let me disconnect for a sec. I will close the PowerPoint. I think the PowerPoint causes this problem. That's weird. Just a second. Let me close all the windows. Can you see it now? It's D.
We can try another beer. Not sure which.
Let me just connect. Here it seems fine, so it seems my laptop is all right. Here's all.
Okay, so let's
Okay.
take this one.
Yeah, it's all right. So. Let me zoom out a bit. Okay, just a sec. Okay, so can you see my mouse over here? So actually the answer is no, you cannot see it. That's not really my mouse. My mouse is 300 pixel above, hidden, and I just show an icon of a mouse 300 pixel below. So whenever I move the mouse really moves somewhere around here, and I just show an icon here. Now, let's say that there is some kind of a game, and I tell the user you have to click on the numbers as they appear on screen as fast as possible. Okay, we measure the time it takes you. And based on our experiments, in about 25 to 30% of the times, what I will show you right now happens well. So the user tries to click on the 1 in here, but really the pointer is above. And then he clicks over the 2. And whenever he tries to click over the 3, his mouse actually appears on the allow to track my location. Okay, so he really clicks it. And then he clicks on number 4. Oh, for some reason it doesn't appear, but you should now see another message. Do you want me to load your video camera? Let me see how it works. Anyway, if we take a look at the here. Oh, something not connected to the internet. I had an internet issue. Let me retry that. Oh, I'm sorry. That's the proxy. I closed so many windows when there was this problem with the projector. So let me retry. Let's start as if you didn't see anything. Okay, let me close this one in here. Okay, so the user clicks on 1, 2, 3. You see now camera 4, 5. Okay, so for some reason it doesn't work. Anyway,
You should not show it to an essay, you know?
and actually see here at the bottom, your current position is more or less 45 meters away from that location. So just by playing and, we found that many people just don't notice the message above. They just click, 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 and they do it as fast as they can. And if you just show it for just a second before they click it, and so once again, it's just a trick. But with HTML5, the ability to track GPS location, the ability to monitor cameras, to listen to your microphone, all these just makes all the security, or all the issues that we already know of, much more dangerous than that. And that's basically it. It was pretty quick. So thank you very much. If you have any questions, please feel free to ask. Yeah.
I have a question about local storage. You say it's very easy to access. Are there any policies, or does anyone have any thoughts about how you might be able to make it less easy? Some kind of coding security or tools that might be used?
Okay, so it's a great question. The question was if someone has any best practices how to manage local storage to make it safer and useful. Someone has any recommendation how they handle it?
It's already, secure is at least as cookie. So yes, you can specify the path to the
So yeah, the idea is to encrypt it, and it's probably as secure or as not secure as cookies. That's true. Any additional questions? Well, thank you very much.